Right, lots of people assumed for question 9 that this was perpendicular, and it never said that it was. So it's quite a sneaky one, quite a tricky question. Right, I'm going to look at this first. It says AB equals BC. That's really important. Every time I find something, information, I put it on the graph. It says D is the point minus 13 naught. So that point there must be minus 13. Right, and then I've got an equation of a line, y equals minus a half x plus 5, and that's ABC. So ABC must go through there, okay, B must be 5, because remember, that's my y-intercept. Okay, I wonder if I can find out what this point C is then. Well, this point C is when y equals naught. So, putting that into this equation, naught equals minus a half x plus 5. So, if I take that to the other side, I get a half x equals 5. I don't want a half x, I just want x. So, x is, so I times by 2 to get rid of the half. So, I times by 2 on the other side. So I get 5 times 2, which is equal to 10. So now I know that C is equal to 10. That's going to really help me. So that's 10 naught, and that is naught 5. Okay, right. Because we know they're the same length, I can then work backwards and say, right, so to get to A, I need to go another 10 along, and another 5 up. Okay, so 10 along from 0 would be minus 10, and 5 up from 5 already would be 10. So the point A is minus 10, 10. Right, I'm going to change my pen colour so you can see this. Right, I've got my coordinate A now, and I'm going to use this to find out the equation of my line AD. So I'm now going to bring a perpendicular down there. Okay, I know that that point there is minus 10, and I know that it's 10 tall. So this difference here is actually 3. So the gradient of AD is how many up? 10 for 3 along. Now don't be put off at this point. I think this is quite a nasty question because of the fractions in it. Okay, so the gradient's 10 over 3. Now I need to know the equation of the line. So I'm nearly there. So I put y equals mx plus c. I've just found out that the gradient's 10 over 3. And now I'm going to use one of the coordinates I know it definitely goes through. So this means when y is 0, x is minus 13. So I'm going to put 0 equals 10 over 3 times minus 13 plus c. So if I take that to either side, I get 130 over 3 equals c. So it's really nasty numbers, and you probably thought at this stage that you might have got it wrong because of the numbers. Right, so to finish off, I've got y equals mx plus c. I've decided that my m is 10 over 3 and my c is 130 over 3. If you wanted to make it look nicer, you could multiply 3 by 3 to get rid of that fraction, and you'd get 3y equals 10x plus 130. A real grade 8 question, that is. Okay. Okay, question 10. They've drawn in that line AC, and actually you don't need it. Okay. It's asking you an equation of a line that passes through C, so it's got to go through this, so that's important, and is perpendicular to AB. Okay, so it's perpendicular to this, and it goes through AC. So that's what they're asking for. So basically a line BC. Right, okay, well we don't know that it goes through B, but that's what they're asking. Goes through C and perpendicular to that. Right, so first of all I'm going to just look at the gradients of this line. Okay, so it's 4 up and 2 along. So AB has a gradient of 4 over 2, which is equal to 2. Okay, so if I want a line that's perpendicular to it, M is 2, which is 2 whole ones. So my new M, so great reciprocal, is going to be minus a half. So M of my perpendicular equals minus a half. So I've got Y equals minus a half X plus C. It's got to go through 5 minus 1. Okay, so that means when Y is minus 1, X is 5. So I get minus 1 equals minus 2.5 plus C. Take it to the other side, plus 2.5. And I get C is equal to 1.5. Putting it all together, I've got Y equals minus a half X plus 1.5. Question 11. Okay, first bit is just substitution. So F equals 1.8 times 20 plus 32. And you'll get 36 plus 32, which gives you 68 degrees. Right, then on the grid, draw a conversion graph. Right, I would be, look, there's a big space here, putting in some figures. So when C is 0, F is 32. This is just Y equals mx plus C. And I don't think people realised. Right, they've already worked out 20, so let's put 20 in there. 20 I know is going to be 68. Okay, what about 10? Well, 10 is going to be 18 plus 32, which is 50. Okay, so you could then plot your graph from there. Okay. So you literally need to start off with 32. Be really careful, it's difficult to see on here, but 32, they're going up in twos, so you start in there. We said 10 was 50, we said 20 was 68, so it's somewhere like here, and then you're going to use your ruler, which I don't have, and read it off there. And then when it asks for what 100 is, you're going to actually show the examiner, read it off your graph, and I think on mine it comes to 36, and they let you have between 36 to 39 degrees C. Okay. Right, question 12. Water's leaking out of 2 containers. It starts to leak at the same time. It shows the amount of water in litres in P, and Q shows in Q. Work out the gradient of P. Use the actual values they've given you. So it's gone 40 along there, so 14 down here. It's down, remember, so it's minus 14 over 40, which is minus 7 over 20. You can leave it like that, or minus 0.35. Okay. One container will empty first. Which one? Right, so P and empties first, okay, but you must explain, it wasn't done very well. So P, because it's empty at 40 seconds, 10 seconds before Q. Not necessarily because of the gradient, it is, but it's not exact enough. Okay, how much water is left in the other container? So at that point you just go up to where Q is, and it's 2 litres. Okay, question 13. Use the graph opposite to find how much Lefner has to pay for units of electricity. She pays the first rates for 100 and then another one for the rest, but she uses a total of 900. So you're looking at 800 more on top of the first 100. Okay, so looking at it, the first 100 is £25. So now I need to look at my gradient for another 800. So why don't we go from 100 to 500, which is 400, and then we can double it. So that's a 25. If I go up to 500, oh, sorry. Let's go back. I go back to 500. I think you'll find it's at £65. So it's gone up £40. So 400 equals £40. So 800 units is going to be double that. It's going to be £80 plus our initial £25 for the first 100. So the total is now £105. Okay, question 14. Again, just read the scale carefully. I think that's 210. That's 140. What's the gradient? It's decreasing, remember, so it's gone minus 210 over 140, which is minus 21 over 14, and hopefully you can see that 7 goes into them, so it's minus 3 over 2. Explain what the gradient represents. Well, look at what you've actually got. So let's put where the minus 3 is. That's centimetres, and that's seconds, and it's saying the depth of water in a tank. Okay, it's going down, so it's representing the rate the depth is falling in centimetres per second. Okay, so 3 nice marks. Nearly there. Question 15. Right, 9 a.m. Bradley begins a journey on his bike. From 9 till 9:36, he's got an average of 15 kilometres per hour. Right, so 36 minutes out of 60 is 6 out of 10, which is 3 out of 5, 3/5 of 15 kilometres. When we say of, we always multiply. So 3/5 of 15, a fifth of 15 is 3, and 3 times 3 is 9 kilometres. Be really careful with the scale. These are, each one is 3 units, so you have to take your time on that. And it's 2 for each one along there. So the first point is there, a nice straight line. Right, it then does a further 8 kilometres to 10:45. So here's our 10:45. So I'm at 9 kilometres. So another 8 kilometres is at 17. So that's 15, 16, 17. So I want to put that point there and join that up. Okay, right, 10:45 to 11, that's a quarter of an hour of 18 kilometres per hour. Okay, so 4 into 18 goes 4.5 kilometres. So the last bit he does is 4.5 is on 17, so that would be 21.5, so that would finish